So we have a simple commonsensical theorem, work energy kinetic theorem for rotational motion. Say we have some random object and we have it rotating around a particular axis. Now I put some effort. I did some work. And if this entire work gets converted to its rotational motion, I'll be able to figure out the amount of work that I do by looking at the final velocity. Compare it with the initial velocity. Basically, how much it was rotating and how much it is rotating now post I do work. Of course, it can increase or decrease. It won't matter. By looking at these two values and doing a bit of math, I'll be able to figure out how much work I have done. Right? So we have a similar law. And this is a cousin of it per se. Say as per rotational, this is how the derivation starts. This is the proof part actually. Sorry, I didn't put the heading. As per the rotational Newton's second law, for a rigid, again, all this is to do with rigid bodies. For rigid body with net torque, I'll just represent it as tau, about a fixed axis is given by, what is the formula? Force is equal to mass into acceleration. Now I'm going to substitute acceleration is equal to rate of change of velocity. So your tau will be equal to I into d omega by dt. Now we will multiply and divide d theta on both sides. Okay. So your tau will be I d omega by, sorry, not both sides, my bad, on RHS. Into d theta by dt. What is d theta by dt? Yes, this is omega. What is d omega by d theta? So that I will replace, as in I will transpose and I put it over here. Because I'll be able to integrate this and I'll be able to integrate this. Now, I'll write a small statement. We're going to substitute the infinitism work, finitesimal work, d capital W, it's not omega, done by the torque. So, right? So this represents that you have a torque working and you have some bit of angle being by an object rotating by some amount of angle. So we have done some small work. So basically I'm going to substitute tau d theta by d capital W. So d capital W is equal to I omega d omega. Okay, now we will integrate both sides. So if I add up all the work, that's what my LHS is, I'll get work. And we have I, which is constant. So my velocity changed from omega I to omega f, and we have omega d omega. And so this integration is half I omega square. So omega f square minus omega I square. I hope you guys are good with your integration. And this is your result. As I mentioned, the work that I do, I can figure it out by looking at what the omega changed from, what value it changed to what. All I have to do is use this math. So work kinetic energy theorem of rotational status states that the net work done by all external torque on a rigid body rotating about a fixed axis is equal to the change in the body's rotational kinetic energy. That's it. Again, it's a commonsensical theorem, and this is how you prove it.